Okay, go ahead, Norman.
Okay, guys, so let me just give you some really simple introduction for this presentation. So, as you know, everything we use today, like apps, websites, and smart devices, all of this runs on a complex IT system behind the scene. So, in this presentation, I will show you how all of this connects, starting from physical hardware all the way to artificial intelligence, kind of showing how each piece works together to power the technology we use today, for example. And the title for my presentation is End-to-End IT Architecture from Hardware to Artificial Intelligence. This is my first slide, physical layer. So as you know, the physical layer is the backbone of all IT infrastructure. So basically, it includes all kind of tangible components like servers, routers, switches, cabling, firewalls. Then we have data centers, we have internet service provider, we have cloud service provider, and I put ISP and CSP here, the part of the physical layer, because you will see later what I mean by this, but basically they have all of those things too, like data centers, servers, routers, switches, cabling. So let me quickly explain each of those. So a server is basically a powerful computer that provides services, data, or resources to other computers called clients over the network. So it's basically a host for websites, applications, files, or databases. For example, when you open a Gmail, your device connects to the Google service that store your inbox and sends or receives emails. Router connects different networks together. It's mostly used for home or business network to connect to the internet. So basically, it decides the path for your data to travel from point A to point B. So for example, all of us, we have those routers at home, right? So you're getting an internet connection from ISP, so the cable runs to your unit, and you might have there a modem, or you might have the router that is provided by your internet service provider, and then from there you might have your router and some other equipment. A switch basically connects devices with the same network, local area network, and kind of ensures efficient communication between those networks or devices. And I have some real examples I will show you later. A firewall is a security device, you know, that software or hardware. It filters traffic coming in and out of your network based on firewall rules you set up or configure. Basically, it's a like security guard that only lets in trusted visitors. And data center, this is the most important thing, is a specialized facility that houses a large number of servers, storage devices, and networking equipment. I didn't put on this slide, I mean, when we talk about physical layer, especially in data center, all of this is inside the data center, right? And there are like so much other equipment, networking equipment, it's not even possible to mention here. But I forgot to put like really important things like UPS, which is interruptible power supply, and then we have also PDU, power distribution unit. So those are really important pieces of equipment in data centers. And again, ISP, CSP, they have all of this. That's why I put them on the first slide. And so this is just a diagram of data centers, and this is all inside the data center. So as you can see, we have file service, web servers, communication service, databases, a lot of equipment, switches, routers, firewall. They're also getting internet, right? Otherwise, this will not be able to function without the internet, without the equipment. I have one more diagram I will show you later and explain. This one, it's a little bit difficult to explain even for me. Networking layer. So this layer kind of connects all the physical devices, kind of again makes communication between them. And so we have a local area network that connects the devices with a small area like an office or your home. So your home is a local area network. Then we have a wide area network, connects multiple local area networks across regions or globally. And again, we have routers, switches, firewalls, we have protocols. I know it might be a little bit confusing this, let me kind of explain. So a wide area network refers to network connections between different geographical locations, which is managed through layer 3 routing. So routers, these operate at layer 3, making forwarding decision based on IP addresses. And then we have TCP/IP or OSI model. So the IP interprotocol operates at layer 3, but TCP is layer 4. On OSI model is layer 3, but on TCP/IP stack it's layer 4. And then we have DNS and DHCP. So these use layer 3 for addressing, but are considered application layer 7 protocols. So basically, the domain name system translates websites names like google.com, amazon.com into IP address that computers use to find each other. So every time when you go to amazon.com, you type amazon.com in your browser, but then DNS server translate amazon.com to IP address, and that's how it finds Amazon website. That's how you're getting data. And then we have a dynamic host configuration protocol, basically automatically assigns IP addresses to devices on a network so they can communicate without manual setup. And DHCP is widely used. We have a static IP, which means like you manually kind of configuring your network adapter, typing in your IP address to, for example, to log somewhere like locally. We'll give you an example like, and I will show you later, I have also a slide for this. I was logging into Cellite, and the Cellite didn't receive any internet connection, so there is no way for me to configure or to do anything, troubleshoot, because there is no internet. So the only way I have to log locally, so I had to, on my laptop, my network adapter, I have to set up static IP address, and I have to set up a VLAN. So it's only if there is VLAN. If there is no VLAN, you don't need to. But if there is a VLAN, you have to set up VLAN to be basically on the same network. And that's how you log locally in some device. I forgot something about this one. I think that will be all for this slide. Okay, so this is the diagram that I want to explain. All of this, it's right here. So we have data center. And in those data centers, we have different servers. You see this data? So all of this comes to here. It's inside of, this is like a cloud infrastructure. It's when we talk about cloud computing, and I know you know this, but some people, not everyone, for example. So when you ask people like, okay, tell me what is cloud computing, they immediately think something in the air, something that it's not visible, and they don't know how to explain. But basically, you have cloud computing at your home. Your computer can provide cloud computing services. Cloud computing means like someone running all of this on your behalf, so you don't need to buy all those equipment and spend so much money and hire people to maintain those equipment and manage everything. Basically, there is someone else who is doing so, but which means like there's still physical location, there's still physical computer equipment, and all of this you accessing through the internet, right? But it's still somewhere in some location, in some data center, on some server. And then we have different types of server, or we have storage, we have database, we have storage, we have server, and everything is inside here. And as you can see, there are some other equipment to manage all those servers, right? And this is you accessing the internet, going through firewall and getting data from here. If you're using ChatGPT, you will go here, all the way here. You're using a web server, file server, whatever, you will go here, for example. Okay, so server and virtualizations. We have physical servers. So they're like basically, again, I mentioned last time, like hardware machines, computers. It's basically computer. And then we have virtualizations. Those allows multiple virtual machines to run on one physical server using hypervisors like VMware or KeyVM or VirtualBox. And then I will explain those different types of hypervisors. But basically, again, when we talk about virtualization, virtual machines, again, I know some people get confused and they still think as something like invisible or like a cloud. Most people have difficulties to explain this. But again, it's same thing. It's computer, physical computer that can kind of provide more than one operating system. So you basically, on one computer, you can run 20 different operating systems, which is like standalone computer. And again, all of this, it's in data center or it's on your computer, on your hardware, and then I will explain. We have two types of hypervisor, type 1 and type 2. So type 1, it's called bare metal. It's commercial, so it's mostly used in data centers, used by companies. And we have VMware ESXi, and we have Microsoft Hyper-V. Then we have type 2. So type 2 is hosted. So it's like VirtualBox, VMware Workstation. So this is basically application. It's not installed on your hardware. It's not using it's using your resources, but it's not physically installed on your hardware. It's just application. So you are accessing those through applications, and those are like cloud computing. And again, they're stored somewhere in some data center on some server and hosted by cloud service provider. I forget something. I'm just checking my notes about this slide. I think that will be all for this slide. Okay, let's do next one. Databases and storages. So here we have, again, this is also everything in data center. Databases are basically structured data like customer info in tables using SQL language or like some flexible formats like NoSQL. And then we have different types of storages like block storage, file storage, object storage. And part of all of this, just keep in mind, I want to mention is backup and disaster recovery. This is where we keep kind of like the whole thing, having the whole infrastructure somewhere backup in case something happens. So that's why we're doing every day like backups, or once a week we have backups and something happen, and let's say there's some cybersecurity kind of like incidents, or we lost data for some reason, or some equipment malfunction. So then we have backups. So keep that in mind, databases and storages. So we keep all things that we need there. So basically, this is also confusing for me. Like every time when I say database, I think database is like a storage, like hardware where you put all those information or data where you store. But the database is basically software system kind of designed to store, receive, and manage data. So it's a brain that knows how and where to find information. But storage, that's where we put the data. It's a physical hard drive or SSD, or it can be virtual like cloud-based block or object storage. So that's a location where the database actually keeps the data, for example, files, logs, backups, and so more. And then, yeah, we have different cloud service providers, And this is one of Amazon S3. It's really, you know this, it's really famous. One S3 object storage for storing backups, images, and logs. And we have Google Cloud File Store. And we have Azure Disk Storage, which is block storage. I think that will be, I mean, I can actually, let me explain a little bit. SQL database. Yeah, so we have different types of database like MySQL, Microsoft SQL Server, and SQL. So SQL, it's a structured query language database which stores data like in structured tables, like basically rows and columns. And it's mostly used for names, addresses, like in order, like kind of order that follows like a predictable format. For example, customer database with tables for users, orders, and invoices will be a good example of SQL table. And then we have NoSQL database. So stores data in more like kind of flexible format like documents or key value pairs. Basically, it's good like for like handling large volumes of unstructured or semi-structured data. And I can't go deep in this, but this is like if you have time, just Google unstructured or semi-unstructured data. It's good to learn about those two. It's really important. And then regarding those block storage, so block storage breaks data into small pieces like blocks, so each with a unique address. So this one, it's really fast and works well like for database and virtual machine disks. And then we have file storage, you know this, data is stored in files and folders like a traditional computer system. And it's used for sharing files across networks. Then we have object storage. This one stores data as objects. Like this one is mostly used like for like images, videos, and backups. So we have file, and then we have metadata, and then you have unique ID in order to identify the image or video. And again, Amazon S3, that's the one that is widely used for images and those videos and logs for applications and websites. I think that will be all about this slide. Cloud computing infrastructure. So let's now talk about cloud computing. Just get my notes, sorry guys. Cloud computing. Okay, I will go to okay, let me first talk and then I will go to the next slide. I have some, just second, here's my notes. Okay, here's my notes, so that I don't forget something. Yes, I have some really good pictures to share about different types of cloud computing services. But basically, again, cloud computing delivers services like compute, storage, networking over the internet, and that's all. Like I said, if you're using ChatGPT or you are accessing some website, so all of this can be provided by someone else, which is a cloud service provider, hosted by someone else on your behalf. And then we have different types of those services. We have infrastructure as a service. So, and let me go now to the next slide. Yeah, this one. And I just took this screenshot. You notice that under each of my slide reference, I didn't steal those pictures. So I put like references under each slide. This screenshot was taken from one of courses that I was taking. It's called Cyber 101, and it was created by Dr. Gerald Auger, and I completed that course. And I took this screenshot. It's kind of like really kind of you'd like to see like how those services are like kind of divided and what they provide. Infrastructure is a service. We have virtual machines, storage, networking. For example, we have AWS EC2, and as you can see here, application data runtime, middleware, and operating system. This is managed by you, and this is virtualization service, storage, and networking. It's managed by cloud service provider. And then I will come back to this one. Then we have platform as a service, application platforms without managing service. So basically, this is all you do. You have application and data. All of this, again, it's managed by cloud service providers. And again, somewhere in data center. And then this is like 100% cloud computing services, software as a service, basically fully managed software. Everything is managed by cloud service providers. And this is you without cloud computing. So all of this, it's on your network. So basically you have all of this in your company. And as you can see, you have to have service, you have storage, you have networking. And when we talk about networking, we talk about wide area network, local area networks. Then probably you will use virtualization, so you will run some virtual machines. And yeah, you will have your website, all of this. And it can be so expensive because to manage all this equipment, you also have to, not just to buy equipment and have space, but you also have to have people. You have to hire people, like, so you have to have network engineer, you have to have people specialized in databases. And again, I'm talking like, depends of the size of your organization. Like it can be small business, but even if it's really small business, it can be so expensive and takes so much money. That's nowadays, I guess everyone, like especially those big companies, they're if not fully, partially using some of those services. And it's called hybrid. So you can have on premises and you can have some of those. So kind of half-half. And mostly like you will do this, like you will not transfer something from here that it's really, I hope you will not, something that it's really, really important. You will not transfer here or here, because once you put everything here, so you're not really you're not having really full control over your data. And this is really important because, those people, I mean, they have really good physical security, right? Like, so those data centers, they have like fences, they have people like security guards, they have cameras, they have so many things kind of guarding, because of course they don't want anybody to get there and plug USB and steal your data. But still, they get hacked, they get compromised. And you know that feeling like when you have something really important and it's next to you or in your house, you kind of feel better, like, and you have control over that, and kind of you can provide better protection. And when you give that something valuable to someone else and you don't see anymore, or you cannot touch it or take it back, whatever, it's hard. Like, so it might get easily compromised. You don't know even like who is accessing, and they're like different. Okay, let me go back to this slide. So this, I didn't explain this. So hybrid cloud. So that means that, as I said, you have your infrastructure, IT infrastructure, and you're also using cloud computing infrastructure. So kind of half-half. And then you have on premises, that's 100% no cloud computing. And then you have public cloud and private cloud. This is one that it's really kind of, in my opinion, really dangerous. Public cloud, so basically you're using cloud services with someone. What does that mean? It means like it's stored on maybe on the same server, on the same hardware, kind of. And it can get, I mean, not really easy, but if it gets compromised. You, for example, when you're sharing resources, you don't know who accessing them and who has access to those resources, because you're sharing with someone. My organization can share like resources, clouds, resources with your organization, whatever, with someone else, and they might get compromised. They might even get compromised by some third-party organizations where they use them like for accounting, let's say for accounting. So small business using third-party company which provides accounting services. So those accounting firms, they have to access cloud storage to manage employees like payroll or whatever, invoices, bills for the company. So the business must give them access. They can get compromised, and that storage can get compromised, and also you can get compromised when you're sharing. So this one is much cheaper compared to private cloud. This is more secured. But I don't know, like if I can decide, I would rather pay extra money to secure my data in my house. I know, for example, I mentioned this before, like, so all important things I keep on external hardware, and it's in my house. And I know people say like, oh yeah, but that also can get compromised. What if someone accesses your house and steal your hard drive? I said, yeah, that's also possible. But compare that, like, so what are chances to someone rob my house and come to take and find hard drive? Okay, maybe 1%, and it's really small chance to happen. But can you imagine if you put on cloud, the whole world, you giving the chance to whole world to get that hard drive when it's in cloud. Anybody from anywhere can try to hack AWS, some of their databases or services, whatever. So it's a huge difference. Yeah. And so this is my last slide, and then I have some personal photos to share and give you the real example of networking. Okay, AI infrastructure. So we know what is AI. AI systems kind of nowadays everyone is using AI, right? So and we can use. So first of all, AI replacing people for mostly those automated tasks where like AI can do it something. Besides that, we can use ChatGPT to ask questions, get answers, to create images, to create videos, to rewrite something. So it's amazing service. And those AI systems, they're using a lot of kind of power, like compute resources. They need large data sets, and they need kind of specialized tools. And they're like AI models. And those AI models, they are trained on data sets, on large data sets. It's machine learning because AI, I don't know how can I say, like it's AI, it's not smart, but AI can learn from us, from our data. So basically what it's doing behind the scene, whatever you put there, every time when you send the question to ChatGPT and you get answer or whatever, you upload some file, some photo or video, AI collects all of this and analyze those data. And AI is learning from those data that we put there. And of course, we have so large databases on the internet, and AI is accessing all of this, gathering information, collecting and analyzing, and it's in putting kind of like puzzle together. Like so, every time, and I also notice this when I use ChatGPT almost every day, and I notice, one day you use ChatGPT for, let's say, you have questions about networking. One day I'm asking ChatGPT about what kind of TV to buy or something totally not related to networking or cybersecurity. And, every day it's something different. And I notice, like, after, like, let's say 5 days, I want to come back to my networking section where I ask so many questions about networking. And I don't want to ask the same questions again. And I can even remember those questions. What I do, I say, hey, do you remember the day when I asked you about networking? Can we go back? And immediately pulls out everything back. So you see how it kind of, it's like keeping everything and kind of learning and kind of like trying to figure out the way how humans think. and is trying to think the same way as humans. So again, AI is trained on large data sets, and there are like different type of training. There is like kind of training versus like inference. So basically training, it's like building the model using, and this is the one that I'm going to explain, using like those hardware resources like GPU. And then there is inference, using the model to make predictions like lighter and faster. And there are like some tools. I will not mention those tools. And I will give you one real example between Apple Intelligence and so I can use Apple Intelligence, whatever. For example, ChatGPT, it's stored somewhere in some data center, on some servers, on some other equipment, and we have CPU on every computer, right? So AI basically cannot use CPUs. For example, this one, NVIDIA A100. So that's like a high performance graphics processing unit, which is designed specifically for AI training, machine learning, and high performance computing kind of workloads. Because again, AI models, especially deep learning models like neural networks, require massive amounts of math and parallel processing. And CPUs cannot handle this efficiently at scale. So that's why we use GPUs like this one. I just pull out this example. NVIDIA is really famous for those. This one, like A100, it's kind of built for that. So basically, it provides like a faster training of large AI models like NLP, natural language processing, or image recognition, or generative AI. Like NLP, that's mostly like when you're using ChatGPT, you're asking ChatGPT questions and you're getting responses. I will give you one example. For Spotify uses AI to recommend songs by processing user listening habits with models hosted in AWS or Google Cloud, actually Google Cloud. Let me talk about Apple Intelligence. So Apple Intelligence was my subject for my final exam for one of my AI classes, and I did some research. For those who have iPhone, the new one, and using Apple Intelligence, it's same thing. It's trained on large data sets, but they have two different types of AI intelligence, or let's say AI models. So they have something in cloud, and they have something on Apple device, on actual device. And the reason for that is because of privacy. They're trying to kind of like protect users, and they don't want to transfer so much data to cloud. And that's one of the reasons, as I mentioned, once it goes from you, it's not that much secure, like being kept like next to you or only on your Apple device. Apple Intelligence is basically mostly trained on data that you provide or you use on your physical device, on your Apple phone. Let me explain a little bit better. So Apple Intelligence, again, have those foundation models kind of trained. So they have one framework. Basically, it's a tool to train those AI models, and it's called AXLearn or AXLearn. I'm not sure that I pronounce correctly, but it's basically a framework. It's an open source AI training system which was released by Apple in 2023. So AXLearn is built on top of kind of on two different models. It's a framework using two different tools. So the one is like, it's called JAX or JAX, and it's a numerical computing library. And the other one is called XLA, and it's accelerated linear algebra. So basically allowing Apple to efficiently train large-scale models across like hardware, including TPUs, cloud GPUs. So this is when I said cloud, The cloud is much bigger, and they can do much more things in cloud, and that's why they're using GPUs. And of course, they also have on-premises GPUs. So let's see if I have. Let me check my notes. I think that will be all. So yeah, when we're talking about Apple Intelligence in cloud, or let's say on-premises, it's doing like the same thing as other AI tools or AI models, collecting data from everywhere. And it's again like collecting, analyzing, learning from this data. But the one on hardware, which means like on your physical device, that one, in my opinion, it's really important because it's designed for Apple users, and they want to know how their clients or customers, iPhone users or Apple users, how they kind of interact with AI. And the best way to get this info is collecting data on your iPhone. Again, every time when you do something, you ask questions. So you have, for example, writing tools feature in your Apple Intelligence. Wherever you go, like if you go to your email, if you go to notes, you're texting someone, you're using Microsoft Teams, wherever you are located, you can use those writing tools. So you can write message, and you can highlight the message, and then you can open writing tools, and there are like different options. You can check for grammar. You can rewrite like to be like professional message. There are like so many features. And every time when you do this, all of this data is collected. So basically that's how AI trained. So those are like personal pictures. It's so hard to see, it's messy, but it's always like this. Don't think like when people talking about server rooms, data closets, whatever they call them, they're like everything like kind of neat, nicely organized. No, it's impossible, I will tell you. It's impossible. First of all, because most of those cabling, it's running through walls, was done like 10 years, 20 years ago, whatever, long time. They're like so old buildings, and so many companies kind of went through those buildings. And each company, they have like their systems, how they build their systems, their techniques, and they leave, someone else comes, do their way, and that's why it's always like this messy. But basically, this is like one, so there are like at least 15 of those data closets on one commercial building, which has like, I think like 44 floors, and this is on the top, the last floor, and this is kind of the main data closet. So this is the router, and this is the main switch. And you can see this like orange cable here, that's like fiber optic cable. So basically coming from ground and giving the internet to this main switch. From this main switch, we have connection to the router. From the router, then going cables down. So, and again, I think there are like 14 more of those rooms with main switches and then user switches, which means like you're getting internet from here, from ground, going through here. There's like big configuration here, and then going to different data closets. And each of those data closets has the main switch. And then from the main switch, internet going to a user switch. And from user switch, then goes to the unit. This is me just running something in one of those data closets, doing the outage, some kind of uncomfortable position. This is also one of those unfinished. And so this is how it looks like when I said like, so you see, this is the main switch. And this main switch getting internet and is giving internet to user switch. This is the user switch, and this is the user switch. Those are called patch panels. It's not finished, but you should see here cables. I will explain to you. So you see this here, like those blue cables. Those blue cables, this bundle of cables going to each unit and coming to these patch panels. So at the end of each of those cables, there is like a jack called keystone jack that is plugged in those patch panels. And then from each port to each unit, there is going connection. So basically, this is like, and this one is a little bit different. You see like how this patch panel has 6 doors, kind of ports. So basically, that means that each unit has 6 cables, 6 outlets inside the unit. So, for example, one outlet in the living room, one in the bedroom, one in other bedroom, whatever. So basically, one unit will be connected to 6 ports, and the next one to 6 ports. Since we don't have enough ports here, we decided to give them only one connection. Only one outlet will work inside the unit. So basically, from here will be only one cable and connected to one port. And that's how unit is getting internet. This is me. I took selfie. My daughter was asking me, also was in the middle of night during some outage. And my daughter was asking me like how it's going. I took the screenshot and sent to her. I just want to share something personal. So this is really interesting. This is Ubiquiti Air Fiber Satellite or radio. I think it's 60. And I will explain. I won't show you the next photo. Okay. So this building has 4 floors. Each floor has 12 units. So basically this building has 48 units, 48 apartments. And because it's a small building, and in order to bring fiber optic cable, it's so expensive. To bring a physical internet connection to the building, it's crazy expensive. And the reason for that, because those fiber optic cables, they're so expensive. And the reason for that is this. So we have a single mode fiber optic cable, and we have multi-mode. So single mode, it's used for long distances. If I'm not wrong, over 45 kilometers. And multi-mode, it's used for shorter distances. So the difference between single mode and multi-mode. Single mode, it's like really tiny cable. I think it's between 5, 6 microns. You cannot even see with your eye the thickness of the cable. And it's kind of, it's a glass, made of glass. And multi-mode has, I think, about 50, 60 microns. It's a little bit thicker. So the difference between those two is when data travels through those cables, so single mode can transfer data faster because the cable is so tiny, and data when going through the cable is going straight. Multi-mode, because it's a bigger diameter, data is kind of bouncing, and we can lose those data packets. So it's not recommended for long distances. So in order to make those cables, it's so hard. Like there's like a special equipment and machines and all those things, and it takes so much time, and it's really difficult because they're like made of glass. They're so tiny, and they're expensive. So what we do, we get internet, we get Wi-Fi basically, wireless connection instead of physical or wire connection. So this air fiber satellite is getting signal up to 1 gigabit, 1000 megabits per second speed from this building here. On the top of this building, so basically this building has a fiber optic cable, physical wired connection to the building. The cable runs all the way to the top, and on the top there is the server room with all this equipment, and at the end the switch. And from the switch, the cable Cat5e or Cat6 runs to the top on the roof, and it's connected to the same radio like this one. So that radio on the top of this building receiving the internet connection from the main switch, and main switch receiving from fiber optic cable and sending signal to this one. And in order to get signal, they have to really be aligned 100%. So we're kind of pointed to each other. It's really hard to align those and configure. But once you configure, you get 1 gig internet speed right here. And this picture was taken before it was kind of finished. Here you see, actually here, this is the opening, and here is RJ45 connection, and from here cable Cat6 runs all the way down to this box. Let me move to the next picture so you can see better. So all the way to the basement from that satellite. This cable, that cable goes somewhere here. Before it goes to the switch, here is like one piece of equipment. It's called PoE. It's called PoE, power over internet, if I'm not wrong. So basically that piece of equipment giving like electrical power to the radio on the roof, and that Cat6 cable on this piece of equipment, there are like two RJ45 connections. So Cat6 from the radio goes to one of those connections, and the other RJ45 connection goes here to the main switch. So that's how this main switch getting like 1 gig internet connection from that radio, and this is how the radio is actually powered with this piece of equipment. And then from here you can see the main switch is giving internet. It's connected to those two switches, user switches, 1, 2, those Cisco switches, 300 SG if I'm not wrong, and this is Cisco Catalyst 2960 if I'm not wrong. And so basically we got the internet to those switches, and then you see those black cables, we call them jumpers. So they're jumping like from each port to each patch panel. Again, there's a keystone jack, and it goes to the unit, and those are cables that are going to units. You cannot see, they're behind the box, and they're here where those are patch panels, and from patch panels each unit is connected to each port. And that's how we bring fast internet to the building that doesn't have a physical wire. We bring over the air using a wireless connection, using satellites, and then running a connection from satellite all the way to the server room, to the main switch, and from main switch we connect user switches, and then we connect units to user switches. That's how we get internet. You know, people sometimes kind of wondering like, hey, I have the internet in my unit, but I don't know how I get this thing, like how is everything set up. So this is just an example. And yeah, I think that will be all for today. I really appreciate you, all of you. Thank you for listening to me and letting me to do this. So if you have any questions now, you can ask me anything.
Any questions? This was a lot of data, Norman. So it may take someone several reviews of this.